Hi Year 11. This week we're going to look at P1, and P1 is the first module in physics. Now it's quite a large module and there's quite a lot to it, so I'm going to take you through how to try and get that nice and small and succinct and do a revise with me to create some mind maps. Now this isn't instead of the webinars this week, this is in addition to. Equally, this video doesn't have to just be used in lockdown. It could well be used to revise up until the end of the year if you are struggling with getting started. So, on that note, let's get started. Okay, so the first thing we're going to do is we're going to, just like last time, we're going to write the name of the module in the middle of the page. Now, I've chosen again to do it landscape this time because I've managed to get my camera to focus landscape. So, I'm going to put P1 in the middle of the page, and I'm just going to put a really simple circle around it. And the first aspect of P1 we're going to look at is energy. And energy is a really complicated idea. So if you were just to Google energy, you're going to get tons of not necessarily the most relevant information. So what we're going to do is we're going to break it down into some subtopics so that you can go away and revise them. Now I should note, when I go through this, I'm going to ask you to put your formulas on this mind map, but what I think would be a good idea is when you do your formulas on here for the various different areas we're going to do, it would be a brilliant idea to have a second mind map where you have literally just got all of the formulas written down. And that's because you will need to memorize those and you'll need to see them really clearly, and perhaps it might be a bit clouded on your mind map. So let's start with energy. So I'm going to take one colour pen. Remember, we want to try and use our colours specifically so that we can break up the topics. And I'm going to write energy here. The next subtopic that we've got is energy resources. Now I know that's a slightly smaller topic, so I'm going to just pop that down here. And energy resources we will be breaking down further as well. Remember, like I said last time, Year 11, you do not have to watch this whole video doing nothing. The idea is you would prepare along with me and then complete this mind map as we go as well. Now, after energy resources, we've got a pretty mammoth topic, which is electricity. And I could break it down smaller, but I do think it's important that we understand how it all links together. So I'm going to just make the electricity topic just this whole space down here, which will hopefully make it easier for me. So we're going to write electricity. Then we have the particle model, which should be something you guys are able to do. But obviously I'm going to break it down further for you. If I could spell particle, there we go. We have got atomic structure. Just going to move this so I can write that there. And finally, we have got radioactivity. Sorry. And radioactivity does include some stuff about atomic structure and particle model, but we're just going to pop it on its own over here. Okay. So those are the basic subtopics that we've got. That doesn't look too bad at the moment, does it? Now what we need to do, and what I'm going to do now, is take you through each section. Now those of you that are joining us for the first time with this video, you need to listen to a section as I go through it and make the smaller subtopics that I go through. And then what you're going to need to do is to pause the video. You're going to pause, you're going to go away and complete that section of your mind map using the instructions I give you. And then you can come back to this video and complete additional sections. This video isn't going to be so useful if you don't use it the way it's intended and revise, like I say, along with me. So for energy, what do you need to know? Well, the first thing you need to know is that there are 8 energy stores. Okay, well, there are probably more than that, but the ones that we need to know about are 8. So 8 stores, and you will need to go away, make sure you know what they are, and make sure you can describe them and give examples of where they are found, if you like. We then need to understand what a system is. So we need to know, first of all, a definition for a system. And then we need to look at the 3 types of system. So we have open systems, we have closed systems, and we have isolated systems. Now, this is all to do with how energy and matter is transferred in and out of a system. And I'm going to give you a brief definition of a system. It's simply one or more objects that work together or that are found together. So system is quite simple, but open, closed, and isolated have different definitions. You also need to understand how energy might be transferred from one store to another. Now, Year 11, you may have heard in the past energy types or energy forms, but that isn't technically correct, and we've really nailed our language a bit more clearly, and we want to talk about energy stores. So there are different ways that energy may be transferred from different stores. So you may have energy transferred by work being done, so physically, mechanically doing work on something, pushing something, which gives it energy. But that energy may also be transmitted via radiation. So the energy from the sun is transmitted through space via radiation. There are around 4 that you need to know of. Now, once you've done those 3, those are quite basic definitions. We then need to get a little bit more specific. And we need to know about different forms of energy. So the first one we need to know a bit more detail about is kinetic energy. And kinetic energy is the energy of movement. And you will need to include a definition. You will need to include the formula. And this is really important. Where I tell you to include the formula specifically, it's because it's one you need to memorize. You will be given, if you haven't already been, a sheet that has a list of all of the formulas you have to know for your GCSE. And I want you to make sure that you know where they fit in the modules. So kinetic energy, you will need a formula for. The next one you need to know is elastic potential energy. And elastic potential energy is exactly what it sounds like. It is the energy stored when something elastic is pulled. So at that moment when you pull like an elastic band or a hairband and it's got that tension in it, and you know that when you let it go, it's going to spring back. Well, whilst it's been pulled and held, that has got elastic potential energy. So here, apologies, it's a long old phrase. Here, you need to know your definition, but the formula for elastic potential energy will be given to you on your revision sheet. Your equation sheet that you get given in the exam. So you don't have to memorize this formula. If you want to get it down because it will help you understand it, that's absolutely fine, but it isn't one you need to memorize. So when it comes to highlighting the formulas you need to know, that isn't one of them. Now, the last specific one that we need to know in terms of a named energy is gravitational potential energy. Now, gravitational potential energy is the energy stored in an object that's been held up high. So the higher up an object is, the more gravitational potential energy it has. And gravitational potential energy makes sense when you think about if you drop something from a higher height, it's eventually going to have a higher top speed than something dropped from a lower height. And that's because it had additional energy stored within it to begin with. And that was in the form of gravitational potential energy. Now, when you do your mind maps, I probably, if it were me, I would just shorten these words. So I might write KE for kinetic energy, EPE for elastic potential energy, and GPE for gravitational potential energy, purely because it will make my work a little bit more succinct, and it's a good way of memorizing it. It will make it easier to memorize. So gravitational potential energy, you need to have a formula. And of course, you need a definition or some sort of description. We also, in energy, need to understand what specific heat capacity is. Now, specific heat capacity is linked to thermal energy stores, okay? And specific heat capacity talks about, it talks about how much energy you need to give to a substance to raise the temperature of that substance by 1 degree. And that can be quite confusing to think about, okay? Because you'll be trying to understand the difference between heat and temperature, which can be quite hard. Now, you need a definition here. The formula is almost always going to be given to you in the exam, and it's quite complicated. So you might want to write it down just so you get familiar with it. Now, there's also a required practical associated with some of these things. I'm going to do a separate video for required practicals after I've gone through each of the modules, because I think required practicals need more time than we often give them, and I'd like to dedicate some specific time to them. Now, last couple of things we need to do for energy. We need to know about something called work done. And work done is when you exert a force over a certain distance. And it also has the same units of energy. So you need here a formula and a definition. Now for all of these, and it will become especially important when we go through electricity, if you're calculating something, so you're using a formula to calculate, an equation to calculate, you also will need to make sure you know the units, okay? So you'll need to know the units of energy and work done. And Year 11, this is a really easy way to get some additional marks, because they're often worth a mark on their own if they haven't given it to you. So it's really, really useful to have those in your head. Very last thing you need to look at for energy are conservation of energy. And it's a scientific law, it's a rule. And that basically means that energy can never be created or destroyed. It simply is transferred from one store to another. And then you need to think about, well, okay, if I'm using something that is using energy, and for example, I'm using a light bulb, which gives out, it transfers light energy from a light store to the surroundings. You also need to think about the energy that it transmits in terms of heat, because we don't buy light bulbs to heat us up, but they do give out heat. And that heat is a wasted energy. So what you also need to understand is the idea of efficiency. And there are some equations here, but Year 11, if you can work out how to calculate a percentage, you will be fine for efficiency, okay? Because it's normally a simple percentage calculation. So that's the subtopic for energy. What I'd like you to do now is to pause this video, go away and complete this. And as I've said before, you might decide to do more than one A4 sheet. You might decide to do an A3 sheet. I want you to fill in all the detail for this subtopic. When you've done that, come back to this video and we will pick up on energy resources. So thank you for those of you who did that, who paused, went away and came back. If you are just ploughing on through, just be mindful that you want to actually make one of these. It's not just about watching it. And so energy resources is a little bit of a shorter topic. In fact, it's a much, much shorter topic. The first thing you need to know is what is a renewable energy resource and what is a non-renewable energy resource. So energy resources are ways in which we can generate energy and normally generate electricity. And you'll have a number of things that you know already. But what we're going to do is make sure that we understand exactly what the examiner wants us to know. So you'll need to tell me what renewable resources are. And I'll also need to know what non-renewable ones are. So just in general, a definition. Now, when you've done that for each of them, I want to know examples. So for non-renewable, you are talking about fossil fuels primarily. So we're talking about coal, oil, and natural gas. For renewable, we could be talking about solar, we could be talking about tidal, we could be talking about wind energy. Wind energy is quite a useful one to think of because obviously we've got the offshore turbines, which is really good because we can see exactly how they've been utilised every day. Now, when you've done your examples, I also want to know, for your examples, I would like to know advantages and disadvantages. Okay, so, you know, what are the environmental impacts of each? So the turbines at sea that we've got, as much as they are brilliant in that they provide us with renewable energy and that they don't pollute in terms of giving off any greenhouse gases, there are people who, you know, do not like the fact that they're there. And that can be for a number of reasons. It can be because some people see that they cause visual pollution, which is where people think they spoil the natural environment. And also, some people don't like them. And actually, this is, you know, a legitimate environmental concern, is that they can be quite dangerous to birds. And if turbines are put up where birds normally migrate to and from, you can seriously impact that species. And that's something that people need to take into consideration when they put up new turbines and windmills and things like that. But that's what I want you to think about, advantages and disadvantages of both, because not everything is as black and white as saying good and bad. Now, that is pretty much all you need to do for energy resources. So that's a nice little short one. It's an interesting one. So I'd like you to pause now, go away and get some information about these things down onto your mind map. And when you come back, we're going to go through electricity. And maybe make sure you've had a bit of a snack before you come back for electricity, because it is a big one. All right, guys, so let's go through electricity then. Now, electricity is a big topic, okay? There's lots and lots here. And the thing I need you to remember as well when we do electricity is that despite the fact there are lots of things to remember, the questions you get asked about electricity can be tricky. And that's because they're often asking you to interpret information. And that's really why it's very important that this isn't your only method of revision. This is a good start, but you also need to make sure that you're doing your past exam papers, that you do in lessons, and that you've been set online as well. So, electricity. Now, the first thing you all need to make sure you know, because they're worth really easy marks in the exams, are circuit symbols. Those are the symbols that you see on, I can't spell, symbols, there we go, on circuit diagrams, and you often will get a couple of marks at the beginning of the paper, nice and easy marks, when you just have to either connect them up or write what the name of the symbol they've shown you is. So make sure you know what they are, make sure you know some key facts about them, and that you can identify them. The next thing you need to know about is what charge is. So you need a definition for charge, and you need to include the equation. And I realise I've said formula quite a lot, guys. I'm going to make sure I say equation now, because that's a bit more closely aligned to what sort of you'll get from handouts and things like that. But I mean the same thing when I say formulas. So you'll also need the equation. All right. Now, the next thing you're going to need to know is about 3 really important things in electricity that I'm going to sort of link together, okay? So you need to know about these 3 things, and they're the properties that you find in a circuit, and they're the things that you'll have to sort of work out practically in order to calculate other things to do with electricity. And that is current, resistance, and potential difference. Now, potential difference used to be known, and still sometimes is known, as voltage. It's measured in volts, and it's measured using a voltmeter. Resistance is it's the property of a component that slows down the charge. So resistance is exactly that. It resists the current. It's measured in ohms, and it's measured using an ohm meter. And current is the flow of charge, okay, and it is the flow of electrons through a circuit every second. And it's measured in amps and measured using an ammeter. Now, these 3 things, you will obviously need to have your definitions And excuse me, guys, I'm not going to write it underneath each and every one because it's going to take a long time. But this is the same for all three. Okay, you need definitions, you need units, you need any key information about them because you'll find lots of information about it. And you also need the equation that links them. And that's how they ask about equations in the exam. They'll often say, what equation links current, resistance, and potential difference? And you will have to remember the correct one. Now, when you've done that, you are also going to need, and I'm actually going to draw a line off of resistance. From these, you're going to need to look at some graphs that show resistance, okay? And you need to look particularly at these graphs for a normal resistor, for a light dependent resistor, and a diode. Okay, now if you don't know what those things are, you need to go away and look at them, because you also will need to be able to tell me some information about light dependent resistors, which are often called Ldrs, and something called a thermistor as well. So I'm going to add that over here. So with the graph, draw a little graph. They'll look a bit like this. I'll show you one of them. So resistor, the graph is going to look a little bit like this, okay? And it's going to be measuring current and potential difference, okay? And it's going to show you just the shape of a graph. That's it. Now, I also want you to be able to tell me the uses of Ldrs, so that's light dependent resistors, and thermistors. Now, basically, these two things have a internal resistance that changes depending on whether it's bright outside or it's dim, and whether it's hot or cold. And they can be really useful. If you think about in your garden, some of you will have solar lights, and those lights will only turn on in low light. And that's because they will have inside a light dependent resistor. And you need to look at specifically how they change in bright light and in lower light levels as well. Equally, same with thermistors. Thermistors, they act differently when it's warm and when it's cold, which is also very, very useful if you want things to turn on, for example, when it gets colder. Think about thermostats, etc. Now, the next thing you need to know is, and I hope that you'll be aware of this already, but you will definitely need to go over it, are series and parallel circuits, okay? So series and parallel. Now, you need to know what a series circuit and a parallel circuit actually looks like. So you're going to need to have some diagrams. But not just that. You're going to need to know how different quantities, different things change depending on whether you're in a series or a parallel circuit. So you're going to need to know about how current behaves in series and in parallel, and how potential difference behaves in series and parallel. And obviously, if I'm doing those two, I'm also going to talk about resistance. Okay, so that's pretty much one area of electricity. Now, there are a few more things that you need to know about, and I haven't really left myself any space for any arrows, but I'll just start one from here. So one of the other things you need to know is you need to know the difference between AC and DC. And no, I'm not talking about the band. I'm talking about the difference between alternating current and direct current. Now, you'll often get a little diagram of each that you can just write down, and you just need to know the uses. That's actually a very, very short bit of the module, but it does come up and people tend to forget to revise it, so please don't you forget. Now, the next thing you need to know, which I always actually really enjoy doing in lessons, is mains electricity. And the first thing you need to know about is the wires in a plug. So you've got the live wire, the earth wire, and the neutral wire. And you need to know the properties of each. You need to know why we have a fuse in a plug. You need to know why we have like a plastic casing on a plug. You need to know how the earth wire can protect you from electrocution if there is a surge. So that might be a nice little diagram as well, a nice label diagram there if you wanted to spruce up your mind map, make it look a bit brighter. Now, the next thing you need to know is about mains voltage. So I'm just going to do a little arrow here. So you need to know about mains voltage, and that's 230 volts. You need to know about why it's at 230 volts and not higher, thinking about safety. From that, you also need to know about the national grid, okay? And I know from my experience with my classes, that has been something that people think is more complicated than it is. The national grid is a series of pylons and cables and transformers that take electricity all around the country from power stations. All you need to really know is about the properties of the cables, why we increase the voltage as we put the electricity onto those cables that move across the country, and why do we then reduce that voltage again as it comes to your homes, okay? So not the longest thing, and again, I know I've said it a few times now, a nice little diagram for that one would really help you. Now, the other thing that you need to learn about, and I appreciate that it is something that actually will be covered up here as well, but you need to know about the equations for power and what power is, okay? So I'm just going to write that here so that we don't get confused with the rest. So we need to know about power, and we need to know some equations, and there are two equations you need to know for power. And we also need to know about energy transfer as well. And that comes into power. So that's electricity, okay? It is a large module and it may take you some time to revise it. And in fact, you may decide actually you want all of that on its own mind map. And I wouldn't blame you. I'm filled up a lot of space and I'm not even writing the extra detail in. But I think it would be a really nice idea to take a lot of space on that one and make sure you really know it. So that's your third section out of 6. What I want you to do now is to pause, to go away and revise that topic. And when you've done, come back and we will have a little look at the particle model. Okay, so the particle model, we're going to move to a different colour. Remember, we try and use different colours to make it clear in our brain the different sections. It's a small effect, but it may help us memorise it. Now, the particle model should be something that you, when you revise it, you quite like revising, because it should be something that's quite simple, because you've done this before. But it's just about taking it in a bit more of detail. Now, the first thing you need to know in the particle model is about density. Now, density is a measure of how closely packed together the particles are in a substance, not how compact compacted or compressed the particles themselves are. That's something that people get confused by. You need to know a formula and a definition, as always, and the units. Okay, now density, if you wanted to remember the definition as the formula, that would be fine as well, okay, because it works, okay? So the formula for density is mass divided by volume, and if you remember the definition as density is mass per unit volume, that's also fine, and that's 2 birds with 1 stone there. The next thing you need to recall is about the changes of state. So the 3 states of matter are solid, liquids, and gases. And what you need to know is, what do we call it when it goes from one to the other? And why is that happening? And that is to do with energy either being added to a substance or that substance having energy transferred out of it. If particles got more energy, they're going to move more quickly. They're going to move further away from each other. And the more space there is between the particles, that means that it's going to turn into a different state of matter. And it's the same in the opposite way. But do make sure you get that down. Maybe a couple of diagrams again there might be helpful. You then need to look at something called specific latent heat. And specific latent heat is often shown with a graph, but there is also an equation to learn. And with specific latent heat, it's simply the amount of energy required to change a substance from one state to another. And you'll see that on a graph because there'll be a straight line. So temperature will maybe be decreasing, and then it will plateau, and then it will come down again. And that area where it levels off, that is the area where the state change is happening. And that's because rather than the temperature decreasing, that energy is actually being used to change the state instead of being given out, okay? And lastly, for the particle model, you just need to know about how the particles move in a gas. And when you heat them up more, what are they going to do? If you cool a gas down, what happens? Okay, nice and simple. Now, that's a really short little bit. That might take you only about half an hour to revise. So what I'd like to do now is to pause this video, go away and revise the particle model, and then come back for the last two sections, starting with the atomic structure. And those of you that have returned, thank you. Those of you that haven't gone anywhere yet, this must be getting a bit boring. You need to make sure you're working at the same time. Now, atomic structure is a real mix of stuff. It's a real mix of things that you will know really, really well. And there are some bits in there that you're probably going to have to go away and revise. So, structure of the atom is the first thing you need to know, okay? And I've put that as a separate one because you just can draw a diagram and label it. So nucleus, what particles are in the nucleus? What do we call the particles that orbit the nucleus itself? What properties do they have? The next thing you need to know is the general size of an atom. And I wish you didn't have to memorize that because it does seem silly, but you have to. The example says you must memorize the size of an atom. And guys, it's just a general number, all right? So you'll just need to make a note of that number there. Now, you'll need to know what the differences between mass number and atomic number are. And how to find that information on the periodic table. Now, in LED Day, Mr. Lamb did a really excellent session on how to revise and how to get your periodic table in the beginning of an exam and just write loads of stuff that you know about on that periodic table. And those two things are really important because you can work all of that out from the periodic table, and that's going to save you loads of time in the exam itself. Now, you also need to know what an isotope is, okay? And in chemistry, you will learn about ions, IONS. And ions are atoms of the same element that have different numbers of electrons. Isotopes are different types of an element or atoms of the same element, but with different numbers of neutrons. And some isotopes are radioactive, which is why we are going to link that into radioactivity in a second. Okay, now the last thing you need to know for atomic structure is the history of the atom. And the best way to revise this is to revise it in terms of the 5 scientists that made really important discoveries. So what you need to do, I'm just going to move this closer, is you need to look at Dalton's atomic model, Dalton even, and he came up with hard spheres, okay? He was the first one to come up with a fully fledged model of the atom. He said that everything was made up of these hard spheres, but you could never break them down. Then you had J.J. Thompson. And he came up with the plum pudding model. So I'm giving you a little diagram next to it, which probably isn't going to help much, but it's just there to help. So J.J. Thompson, plum pudding model. Very, very important. Then after Dalton, you had Ernest Rutherford. And Ernest Rutherford did a really famous experiment called the gold foil experiment. And in the gold foil experiment, he realised that actually atoms were made up of a nucleus in the middle, and there was the negative charge rotating all around the outside. Now, Niels Bohr, he's the only non-English scientist on our list. He was actually on Ernest Rutherford's team, and they worked together. And Niels Bohr realised that the electrons weren't just whizzing randomly around the outside, but actually there were really specific energy levels. and we draw those as shells. So Niels Bohr came up with the idea of electron shells. And the last one, who's only very recently getting acknowledged as much as he should do, is James Chadwick. And James Chadwick proved the existence of neutrons. And that's a little bit difficult for me to draw, so I'm just going to draw an arrow to one of the particles in the middle. Okay, now neutrons were really difficult to discover because they don't have charge, and so it can be really hard to identify them with with the experiments of the day. Okay, so I've given you a really short introduction to these 5 scientists. You don't need much more detail than that. You just need to know what their model was, how they sort of came up with it, and how they built on their predecessors' work. Now, we're going to move on to the last section in just a second. So what I would like you to do now is pause, go away and revise the atomic structure section, and then come back and we will look at radioactivity. Okay, so radioactivity seems to be one that people think is super duper hard, but it's not, okay? It's just got some weird squiggly Greek letters that confuse us, but actually, once we get into it, it's not as difficult as it may seem. What I will say is this may be one of the areas where you may want to reach out to your teachers or pay particular attention to the webinars for some of the sections, because it might be a little bit more complicated to understand from bite size, etc. So, radioactivity. I want you to tell me what it means if something is radioactive. Now, radioactive means that it's got an unstable nucleus and that it's going to emit some form of radiation. And radiation can be a particle, it can be a collection of particles, or it could be a wave, okay? And there are some definitions you need to know that are linked to radioactivity. So you need to know what activity is, and that's to do with a radioactive element. You also need to know what something called count rate is. Again, that's to do with how radioactive an element is. And the next thing we need to look at are the different types of radioactive decay. Okay, so we're going to look at alpha decay. We're going to look at beta decay. And we're going to look at gamma. Now, I've left a lot of space here because for each of these 3, I need to know what the actual decay particle is. So for alpha, it's 2 neutrons and 2 protons. It's what we call helium nuclei. I need to also know an example of a decay equation. So if something decays via alpha decay, what does it look like? So you write that down as you have an element, you have the numbers written above and below, so the mass number and the atomic number, then you draw the alpha decay, and then you see what you're left with at the end. And I need to know some properties as well, okay? I need to know, does it get stopped by paper? Does it get stopped by foil? Does it get stopped by lead? Is it very... does it travel a long distance? Does it not? Is it harmful when you come in contact with it? Is it harmful if you ingest it, for example? The answer to the ingest bit is yes. But I need to know all of those 3 things for each of these, okay? Now, if you're somebody who's deciding to do this as a set of flashcards rather than a mind map, you would do only 3 flashcards, but you would do them really detailed. Now, after you've done that, you need to also think about what a half-life is, okay? And half-lives are to do with how long it takes for the radioactivity of a substance to go down by half, okay? So how long does it take for it to be half as radioactive? And with radioactive elements, for some of them, the reason they're so harmful and so dangerous is because their half-life is exceptionally long. If you think, if the activity goes down by half of something that's radioactive, then it's going to be half as harmful. And so we want it to keep going down by half quite quickly to get to a nice, safe concentration. But unfortunately, like I've said, some of the radioactive half-lives of some of the substances that we talk about are actually really, really, really long, and therefore makes it very dangerous still. You also need to talk about the difference between contamination. So if you physically ingest or you get a radioactive element on you, physically on your skin, okay? And what happens, what is irradiation? Okay, and irradiation is simply where the radioactive particles or wave, the radioactive decay, might pass through something. Okay, so you need to think about what the difference is and which one of these is more harmful if you're contaminated or if you're irradiated, because they are different. So that is a very, very detailed, but I hope quite straightforward introduction to the topics that you need to revise for P1. Now remember, P1 is an entire exam paper. Okay, so it's not supposed to be short. This is everything you will need to know for one exam paper. And you will, well, long term, the expectation is that you would have done 6 of these. What that looks like now, we're not 100% sure, obviously. Now, what I want you to do is make sure that you take your time and you do each of these sections. Okay, pause the video where you need to, come back to it if you need to. As always, Year 11, if you have any feedback at all for me, please let me know and I will do some things slightly differently in these videos. I can do videos on specific topics if you want me to look at the maths in science, if you want to look at how to answer a 6-mark question, all of those things. Do let me know and I will do my best to do them for you. Okay, thank you for listening and watching and revising with me, Year 11, and I will see you very soon.